Dividing complex numbers. In this video, we'll talk about how to divide one complex number by another. Now, this assumes that you already know what complex numbers are and how to add, subtract, and multiply. Actually, multiplying is what we really need in order to understand dividing. So, if you have not watched those videos on complex numbers and multiplying complex numbers, I have videos on them. So, please watch them first and then come back to this. Now, let's get into dividing complex numbers. A complex number has this form, a plus bi. And a is called the real part and b is called the imaginary part. So examples, I can take a to be negative 2 and b to be positive 3, or I can have 5 minus 7i, and sometimes I may not even have any real part. So I may just have something like negative 3i, negative 10i, and I may not even have imaginary part. In that case, it's going to be just a real number, which you already know how to divide real numbers. So we'll focus on complex numbers that look like this. Either they have real and imaginary part, or they have just imaginary parts. So these are purely imaginary numbers, and these have both real and imaginary components. Now I want to see this as a binomial because it has two terms, negative 2 and 3i. Here, this is again a binomial with 5 and negative 7i, but these are monomials, 3i and negative 10i. Look, I'm not adding or subtracting anything in this particular expression. And same thing here. Even though there is a negative 10, it's not subtraction. I'm not subtracting anything. It just happens that the coefficient of I is a negative number, which is negative 10. So let's keep that in mind. And there are really two kinds of division problems for complex numbers. Now, let me begin with example 1. I can have any numerator. So numerator usually is not going to create a problem. The focus should be on the denominator. So I'm going to consider denominator which is a monomial. So say 5i. Now if the denominator is a monomial, then what I want to do is I don't want to have an I in the denominator. So how do I get rid of that I? I'm going to use this property. I square is equal to negative 1. So look, one I is bad, but if I have two copies of I, that's actually good because then I can get rid of the imaginary part. So I'm looking at my problem, 2 minus 7i divided by 5i, and what I'm going to do is I'll try to find a way to introduce another I in the denominator. And how do I do that? Well, I can multiply and divide by I. And you know how to multiply two fractions. You multiply them across. So when you multiply that, you get, for the numerator, it's going to be 2 minus 7i times I. And in the denominator, it's going to be 5i times I. But I times I is I square. And that was the whole purpose. I wanted to get an I square in the denominator. Now what happens here is, in the numerator, since you have a binomial multiplying a monomial, you got to distribute that. So you multiply I with 2 and you get 2i, and then you have minus 7i square, and then in the denominator you have 5i square. So let's simplify in the next step. So just keep going. I square is negative 1. And what I square does is it flips the sign, right? Because you're multiplying by -1. And we spend a lot of time talking about that in the multiplying complex numbers videos. So the numerator is 2i plus 7 and the denominator is -5. And look, now we don't have I in the denominator. So I can write this as, I can think of this as a binomial divided by -5. That's what it is. So I can divide each of the terms of the binomial. So 2i over -5, I get -2/5 I, and I have to divide 7 by -5. So that's -7 over 5. So that's a complex number where now I did not write in this form a plus bi. If I wanted to write it, then I would have to switch. I would have to write the real part, which does not have I in it first. So that's a -7/5. And the imaginary part is -2/5. So -2 over 5i. So when you divide by a complex number, you again get another complex number. And that's what we want our number system to look like. Whenever we divide, multiply, add, or subtract, we want to get in the same number system. And complex numbers is one such system. All right. So that's how you do. So if you summarize, if you want me to summarize, then I have to divide by a monomial that has an I in it. So single I is bad. I wanted to introduce another I in the denominator. So I can't just introduce in the denominator. I got to multiply the numerator as well. So if I multiply by I over I, I'm not changing anything. I'm not changing the value of this expression. But I'm rewriting it in such a way that the denominator now would not have an I, imaginary part, in the next step. So thinking ahead, I know I square will eventually become -1. And so that's why we multiplied and divided by I. And when you multiply by I, now you got some work to do in the numerator. You got to distribute that I and then simplify. Wherever you see I square, change it to -1. So -7 would become +7, and +5 in the denominator becomes -5. And then just rearrange. So you're dividing by -5, and at first you would get this, but if you want to write in the a plus bi form, like here, you would rearrange. All right, I think we spent a lot of time on that example. Let's talk about one more example. And in this example, we won't spend as much time. We'll just do it. So say I have -3 plus 5i divided by -2i. So I have a monomial in the denominator that has I in it. So I'm going to multiply and divide by I. And what do I notice? I got a numerator which is -3i plus 5i square, and the denominator is -2i square. So now it's time to replace I square with -1. We would have -3i minus 5 over +2. So this would be -3 over 2i minus 5 over 2. And if you want the a plus bi form, that would be writing the real part first, -5 over 2, and then -3 over 2 is the imaginary part. You would write that next. All right, let's do maybe one more example. Say you have 4 minus 7i divided by -3i. So just like in example 2, I'm going to multiply and divide by I. That changes the numerator to 4i minus 7i square divided by negative 3i square, which turns it into 4i plus 7 over positive 3. And if I'm thinking ahead and if I want a plus bi, then I would write this part first, 7 over 3 for the real part, and then the imaginary part is 4 over 3 because that's what I have with I. All right, so these three examples told us that if you have a monomial with an I, you just multiply and divide by I. Now, in example 4, what I'm going to do is have a binomial in the denominator. So I have a monomial in the numerator, but let me take a binomial. So 3 minus 4i maybe. Now, when you have a binomial in the denominator, then you just can't multiply by I over I, because if you multiply by I over I, then this 3 would turn into 3i. You'll get rid of I here, but you would introduce an I there. And that's where you want to think about complex conjugates. So we learned that if you multiply any complex number by its conjugate, your answer is going to be a real number. Which means if you have a binomial, 3 minus 4i, then what you really want to multiply with is 3 plus 4i. Because that's the conjugate. Now, I can't just multiply the denominator, I got to multiply the numerator as well. That way, I'm not changing the value of the fraction. And since this is a binomial, let me put this in parentheses so I don't get lost. Now the numerator is 3i multiplied with this binomial. Anytime you're multiplying a monomial with a binomial, you distribute it. So 3i times 3 is 9i. Then 3i times 4i is 12i square. So 12i square. Now what is the formula for a minus b times a plus b? So let me remind you this formula. It's called difference of squares. If you don't know this, then try to remember this. It makes things really fast for you. Now, you can always get it by foiling, but what happens is the middle terms, it's a square minus b square. Hold on, let me rewrite this. It's a minus b times a plus b equals a square minus b square. So when you multiply these two binomials, when you FOIL them, you get 4 terms, but the middle 2 terms cancel each other out, and you would be left with just that. Now, try to remember this. It's a great tool. It makes things really fast for you. So anytime you see an expression like this, a minus b and a plus b, and you're multiplying them, all you have to do is simply simply square the first, and then it's a minus. Your answer would have minus. Square the second term. The second term is 4i. You got to square that. All right, so let's continue right here. It does not matter. I think I'll need one more step. So it's going to be 9i plus 12i square becomes minus 12 over 9 minus, Now remember, if I have to square 4i, I got to square both 4 and I. So 4 square is 16, I square is just I square. So this becomes 9i minus 12, 9i minus 12 divided by 9 plus 16. So that's going to be 9i minus 12 divided by 25. And if you want to write it in a plus bi form, you would write this first, negative 12 over 25 and plus 9 over 25i. All right, let's look at one other example. And in this example, I'm going to use this formula, difference of squares. So say I have a monomial again in the numerator, 7i over 2 plus 3i. So I'll multiply and divide by the conjugate of the denominator. So that's going to be multiplying with 2 minus 3i over 2 minus 3i. The numerator becomes 7i times 2, which is 14i, minus 7i times 3i. I'm multiplying positive with a negative. That's why I wrote minus. 7i times 3i is 21i square. And the denominator simply becomes 2 square minus 3i quantity square. So this is going to be 14i minus 21i square is plus 21 divided by 2 square is 4, and when I square 3i, I get 9i squares. But there's a negative outside which is not squared. So that negative remains in place. You're only squaring the 3 and I. So you get 9i squared. So this is going to be 14i plus 21 divided by 4 plus 9. So that's going to be 14i plus 21 divided by 13. Now, if you want to write in the a plus bi form, you would write the real part first, 21 over 13, and then you would write the imaginary part, which is 14 over 13i. All right, in both of these examples, I put the numerator a monomial because that would make the problem a little bit simpler, but it works the same way even if I had a binomial. Now, the thing to notice is the denominator was a binomial, and we multiplied by the complex conjugate of that in order to get something like this, a real number. Now, in the next example, I'm going to have both numerator and denominators as binomials. So negative 3 plus 2i divided by, let's say, 4 plus I. The conjugate of 4 plus I is 4 minus I, and that's what I want to multiply both numerator and denominator by. So I'll be foiling both numerator and denominator. They are both binomials now. So if you want, you could put them in parentheses. So I have negative 3 times 4 is negative 12. Then negative 3 times negative I is positive 3i. Then 2i times 4 is positive 8i. Then 2i times negative I is negative 2i square. And the denominator is nice, a plus b, a minus b form. So all I have to do is square the 4. And then remember, the formula is minus b square. B square is I square. So it's time to simplify now. The I square is negative 1. That turns this into a positive 2. And look, we can combine these two like terms, 3i and 8i. So let me rewrite my expression. I'll write negative 12, and maybe I'll combine these two, plus 11i. and the negative 2i square becomes positive 2. And the denominator becomes 4 square is 16 and minus I square. I square is negative 1, so this is going to be plus 1 because it's minus of negative 1. All right, now we can combine these real parts. Negative 12 plus 2 is negative 10 plus 11i over 17. If you want to write in the a plus bi form, you would write that denominator separately. Negative 10 over 17 for the real part plus 11 over 17 and I. So your real and imaginary parts could be fractions. They don't always have to be nice integers like in the problems that we began with. Now let's look at one more example, and this time let's do it a little bit faster. So what about negative 5 minus 2i divided by 2 minus I? So we'll multiply and divide by 2 plus I. So, and now when you multiply the numerator, at first you'll have 4 terms. So negative 5 times 2 is negative 10, then negative 5i, then this will be negative 4i, and this would be minus 2i square. And this is going to be 4 minus I square. So this is actually positive 2, right? So what's negative 10 plus 2? I can combine these two actually. That becomes negative 8. And I can combine these two, that's negative 9. And this is 4 plus 1. So I can write this as negative 8 over 5 and minus 9 over 5i. All right, so these examples should give you enough practice. If not, you might want to watch them again. And I spent a lot of time in the first few examples, and then I did a little bit faster. Now, I have some practice problems, the answers of which you will find in the video description. So there are 10 problems. The first 5, I have just a monomial in the denominator. The numerator is either a monomial or a binomial, but that does not matter. So you just multiply by I over I here. Now in the next set of 5 problems, you have a binomial denominator. Your numerator is monomial, but denominator, sometimes the numerator is monomial. But the denominator in all these 5 problems is a binomial. You multiply and divide by the complex conjugate, do it carefully, and check your answer with the one in the description. And I'll see you in the next video. Thank you.